This video illustrates the RiskFP tool. RiskFP serves as basis of the development of the service developed for insurance sector in the forest demonstrator of the H2020 OASIS insurance project. RiskFP is the fire risk management help tool. It allows to explore viability of the fire behavior in the local zone based on the landscape patterns. Landscape patterns of essentially the weather viability is highly impacting the fire behavior, but also the local vegetation changes and topography changes, viability of the slopes and of the aspects of the zone. It then allows to generate realistic events in this local zone, to build event database, hazard database for the OASIS context. All fire events which are generated are provided in OASIS form, compatible with OASIS format. This prototype has been developed in two Climate-KIC sponsored projects, the RiskFP market analysis and tool design project in 2015 and the 2016 project OASIS Plus, where we did develop this prototype we will see now. RiskFP is a web-based platform which has been designed and developed by Aria Technologies, with we will see with help of the partners. We will illustrate RiskFP for its initial purpose for forest managers here in southeast of France, public forests. So ONF International has gathered input data from the French National Forest Service in a zone near Marseille city. Marseille being here. We have full coverage of high resolution topography and vegetation map in this zone. Here are public national forests. We will illustrate here the principle of the tool. The first element is to choose a weather situation, weather pattern, which can be from non-extreme weather pattern to extreme weather pattern, very prone to extreme behavior of fire. We have then two types of outputs. The first is a view of a local fire risk map in the tile according to the topography viability and few changes. And then we generate the fire events, as we mentioned, for the hazard database. The first step for both of these elements is to choose the weather situation. Here the weather days in a database of reduced database of 2 years. Usually we will use 10 years or 20 years of data. Here we have 2015, 2016 days of weather parameters, and we provide non-extreme to extreme situations according to the variables atmospheric instability and vegetation dryness, fully driven by the weather patterns. In the OASIS H2020 insurance project, this definition of extreme pattern will be largely improved. That's one of the key work in the OASIS H2020 inference project. We first going to view a map calculation. So we need to generate a map according to weather situation. So we again select one situation. So let's take one relatively extreme situation, one of the most extreme, and we define that we want a risk map for this weather situation of the 20 September 2015. We have in our basket of simulation high risk mapping 20 September 2015. And we launch the simulation. The basket can contain many simulations at once. Here we will go sequentially. So now we go generate for the same day a fire spread scenario. We have here a memory table which shows what was launched, what was already launched before this demo, and here we see our simulation is currently launched. We'll come back to it later. More or less simulations duration is around 30 seconds. Let's define now spread scenario. So we start with the same step of defining our weather day and then defining the other spread parameters. So the spread duration, which could be changed from duration of 6 hours of fires, increased. And now we will put fire starts. Put fire starts on the map. And from here, we increase the number of fire starts. Let's after 1 hour from the initial time. We put second. Start here. And we save it to the basket. Let's review the current simulations. The fire risk is okay. We're going to see the outputs. And in the basket, we have our spread simulation just defined. Spread scenario 20 September 2015. And let's launch it. Meanwhile, so let's come back to the list of simulations. Meanwhile, we will look at our risk map simulation. Let's show it. Here we are. Risk levels going to red as the highest level. Remember, we are in high risk situation, so many zones align as bad weather conditions with also some vegetation prone to burn, and sometimes topography is adding to the risk level. So the fire spread is still ongoing calculation. Actually, these calculations go to TechnoSilver Wildfire Analyst web server system. And once the simulation are processed, the outputs are sent back to Aria Technologies web server system. We see now the fire spread is ready. So let's show. Okay, we have impact of the two starts acting differently at their level. So here is the idea that we could run many different simulations in the basket and have it calculated simultaneously, and we more or less need 30 seconds to get one output. Last step is that we're going to get view for this object of the total area, and we could save it then to OASIS format to build the OASIS hazard database that we need in that local zone. For the conclusion, we have here demonstrated the basis we start from for the H2020 OASIS insurance project to adapt it to insurance needs. So our partners in OASIS insurance, so same as in RiskFP, 1F International, Technosilva, and so we have investigated with forestry for end users, and we have now designed demonstration zone in Portland, near Portland, Oregon, public forest, and also in Australia, in Victoria State and New South Wales for property insurance. So our partners pick Imperial College, McMaster University, Freshfield, and Better Point will help us additionally to the other partners to achieve our goals of making this tool adapted to insurance needs. Thank you.